Hi, this is Mrs. Jacobs, Naperville North physics teacher, here to do a tutorial about how to write a math model from a linear equation. The first thing I want to talk about is what is the format of a linear equation and how is that different than a math model? A linear equation is simply a y equals mx plus b equation, where you have your two variables, y and x, you have your slope, which is n, and your y-intercept, which is b. Hopefully you're familiar with that kind of equation from math. In physics, we take this linear equation and we make it into a math model. It's really similar. The difference is we're using words and units for our variables and our units, okay? So this will be a word or a symbol from the y-axis of your graph, okay, for the y variable. And the x variable will be the same word or symbol from the x-axis. Okay, so we're replacing our y and our x with what really was the y variable, what really was the x variable, to make it more meaningful in terms of physics. Then the slope will be a number, okay, like 2.5 or 7.2 or negative 44.8. And then there will be a unit tied to that number for the slope, okay? And it will be the unit of the unit of the y over unit of the x, okay? Because it's going to be a rise over run unit. Usually I put these in parentheses to kind of distinguish between the x variable and the slope. Plus the y-intercept. The y-intercept will also be a number. It'll be 100 or negative 44 or something like that. And then there will be a unit tied to that number, and that will be the unit from the y-axis, since the y-intercept was where it intersects the y-axis. Before I go through a specific example, I want to talk about the difference between units and variables. On your x and y axis, you're going to have words, position, and time. Those are my variables. That's what was measured. I measured time. I measured position. The unit of measurement is how that variable was measured. This was position measured in centimeters. That's the unit is centimeters. Seconds would be the unit of time, okay? So every axis will have a variable, and then in parentheses will be the unit. So this was time measured in hours. This was money earned measured in dollars. Money earned is the variable, dollars is the unit, okay? Now, here are my steps for writing a math model from the linear equation. I'm going to tackle steps 1 and 2 first and show you an example. Steps 1 and 2. I'm going to replace the y in the linear equation with the y variable from the y-axis of the graph. I can use the word or the symbol. I do not need units in this case. Okay, let me show you my example. Here's my example. Here's my graph. Here's my linear equation, y equals negative 2.6x plus 80. The first thing I'm going to do is I'm going to replace the y with what was the y variable? It was speed for my y-axis, not centimeters per second. That's the unit, just the word speed. Okay. I'm going to replace the x with the x variable, which was time. And that's steps 1 and 2. I don't need units with this. I just need the two variables, speed and time. Step 3, I'm going to tackle the slope. I'm going to write the number for the slope and the unit for the slope. Okay. The number is negative 2.6. That doesn't change. But what's the unit that goes with the negative 2.6? It's the rise, the y-axis unit over the x-axis unit. The slope is rise over run. And this is where I use the unit. So here's where I'm going to use centimeters per second and seconds. So if it's rise over run, my unit is going to be centimeters per second over seconds. Y-axis unit over x-axis unit. And again, I'm going to put this in parentheses, the time, to distinguish between my slope and my x variable. I'm done with step 3. Step 4, I'm going to tackle the y-intercept. Write the number of the y-intercept and the unit for the y-intercept. And that comes from the unit from the y-axis. My number is 80. The unit that goes with 80 is from the y-axis. centimeters per second. Okay. You can also replace speed and time with symbols. So this would be an acceptable answer as well. Negative 2.6 centimeters per second, S and T for speed and time, plus 80 centimeters per second. Okay. This is practice problem 2. Money earned in dollars and time in hours on the different axes. Here's my linear equation. I'd like you to pause this and pause this video and try this out, and then I will show you the solution. Okay. Here's the solution. Money earned, replace the Y. Time, replace the X. Those are my two variables. My slope was $14 per hour, the correct unit, plus $10 for the y-intercept. And the symbol dollars can go either after or before the 10. It doesn't really matter. If I wanted to do it in symbols, I could do M for money earned and T for time, but that wouldn't change my slope and that wouldn't change my y-intercept. Okay, hopefully this was helpful for practicing going from a linear equation to a math model.